Good evening, GCC, College Algebra, MAT-15 something. We finished up with Chapter 12, and we're going to move on to Chapter 13. Now, in Chapter 13, it's a long chapter with a lot of stuff in it, and we only want to hit a couple of topics out of Chapter 13. The first one is sequences. So as we look at 13.1, and as you look at it and look through the textbook, you'll notice that we're not even going to do everything that's in 13.1. First, what is a sequence? Mathematically speaking, a sequence is a function whose domain is the set of positive integers. That's the domain, not the output, the domain. Another way of thinking about a sequence, a better way of thinking about sequence is, think about it as an ordered list of numbers. The ordered list of numbers is the output of that function. All right. So, for example, so let's do an example here. Example. So I need a function, and then I'm going to put in just the positive integers to find the output, which generates the sequence. So if I have something like f of x equals 1 over x. So there's my function. The sequence is the outputs. So I'm going to look at f of 1. So now I'm only using positive integers, starting with 1. 1 over 1 is 1. F of 2, 1 over 2, is 1/2. F of 3, 1 over 3 is 1/3. F of 4, 1 over 4 is, well, 1/4. Now, here is the sequence. So the sequence that has been created by this function is the sequence 1, 1/2, 1/3, 1/4, 1/5, ... And the ... we refer to that as an ellipsis. And then in general, 1 over n. This is my first term, my second term, my third term, fourth term, fifth term, all the way up. And then this is called the general term, the term in general. And of course, the sequence would keep going, ... All right, so the domain is positive integers, f of 1, 2, 3, 4, and so on. The output can be anything. So this is one example of a sequence. Let's take a look at another one, something maybe a little bit more interesting. I'm going to pick something out of the exercise set. Let's see, I have you doing 17 and 19 and 21 and 23. Let's do something like number 28. So in the exercise set, number 28 says that C of n is n squared over 2 to the n. And it wants me to generate the first 5 terms. So find the first 5 terms of the sequence created by that. Well, C of 1 would be 1 squared over 2 to the 1 would be 1/2. That's my first term. C of 2, my second term, would be 2 squared over 2 to the 2, which would be 4 over 4, which would be 1. That's my second term right there. C3, my third term, would be 3 squared over 2 to the third. 3 squared is 9. 2 to the third is 8. That would be my third term. C4, my fourth term, would be 4 squared over 2 to the fourth. 4 squared is 16. 2 to the fourth is also 16. That would be my fourth term. And then finally, my fifth term would be 5 squared over 2 to the fifth, which would be 25 over 32. So the sequence, the first 5 terms are, there's my first term, second term, third term, fourth term, and fifth term. Those are the 5 terms generated by that sequence. All right. So we have the function that generates the sequence, and then the actual terms. Now notice, we only put in positive integers, 1, 2, 3, 4, 5, and then I plug it in for 1. I plugged in 1 for n, and then 2 for n, and then 3 for n, and then 4 for n, and then 5 for n, and simplified. Just looking at this ordered list of numbers, a half, 1, 9/8, 1, 25, 32, and so on, you may or may not recognize a pattern. Sometimes the patterns can be very hard to see. Given just the sequence, working backwards to find the formula, very difficult skill. And that is a skill you'll explore in the next class, but not in this one. All right, let's take a look at another example. I want to deal with one that's a little bit more hard, a little bit more difficult. Consider the sequence b of n equals -1 to the n plus 1 times 2 over n. All right, and I want to find the first 5 terms. Oh, I think this black pen's about to die on me. All right, so b sub 1, the first term, would be -1 to the 1 plus 1 times 2 over 1. So notice, this is more difficult formula, but I'm doing the exact same thing. I'm plugging 1 in there for n. I plugged 1 in here and 1 in there. So 1 plus 1 is 2. I'm going to get -1 squared times 2 over 1 is just 2. -1 times -1 is +1 times 2 is 2. My first term is 2. My b sub 1, my first term is 2. b sub 2, my second term, -1 to the 2 plus 1 times 2 over 2. -1 to the third power times 2 over 2 is 1. -1 times -1 times -1 is -1. Times 1 is -1. My second term is -1. My third term, b sub 3, -1 to the 3 plus 1 times 2 over 3. I'm going to get -1 to the 3 plus 1 in the fourth power times 2/3. -1 times -1 times -1 times is +1 times 2/3 is 2/3. b sub 4, my fourth term, -1 to the 4 plus 1 times 2 over 4. I'm going to get -1 to the fifth power. 2/4 is a half. -1 to any even power is a +1. To odd powers is a -1. So -1 times a half is -1/2. And then finally, b sub 5, my fifth term, -1 to the 5 plus 1 times 2 over 5. -1 to the 6th times 2/5. To a positive power, it's 1 times 2/5. I get 2/5. So there's the first 5 terms of that sequence. Now, these formulas can just get more and more complicated, and just kind of generating them. But just take it one at a time. The first term, plug 1 in for n and simplify. The second term, plug 2 in for n and simplify. All right, before we move on, I want to look at a new symbol. This is a new symbol we're going to be using. It's called the factorial symbol. I'm looking for a black pen. There we go. Factorials. And the factorial symbol is an exclamation point. And we say factorial. And 1 factorial means is just 1. 2 factorial means 2 times 1, which is 2. 3 factorial means 3 times 2 times 1, which is 6. 4 factorial means 4 times 3 times 2 times 1, which is 12 times 2, 24. 5 factorial means 5 times 4 times 3 times 2 times 1, which is 120. 6 factorial, do you see the pattern here? Are you seeing the pattern? 6 times 5 times 4 times 3 times 2 times 1 equals 720. Your calculator actually has a factorial button on it. Let me show you. So on the calculator, if I wanted to do, what is 7 factorial? All right, so what I'm going to do is I'm going to type in 7, and then I'm going to go to Math, and then I'm going to go over to Numbers. No, I'm not. Where is it? Math. I'm going to go over to probability, P-R-O-B. It's under the probability. Yep, there it is, number 4 under probability. Exclamation point, so 7 exclamation point apparently is 5,040. So the calculator will do factorials for you. There is one really weird, now that you've looked at the pattern, can you guess what 0 factorial would be? Let's try it on the calculator. So I'm going to go 0, and then I'm going to go to math, go over to probability, go down to number 4, exclamation point. 0 factorial is 1. I know, it's very counterintuitive. It seems like it should be 0. Whenever you multiply 0 by anything, don't you always get 0? Well, apparently not. 0 factorial is 1. There's proofs for this, but you really don't want to go into them. The best thing to do, unless you take like a number theory class, some sort of theories class, they'll explore why this really works. But really for here, it's just good enough to know, to memorize that 0 factorial is indeed 1. We do have a textbook definition of factorials. The textbook definition of a factorial is this. Oh dear, excuse me. N factorial is n times n minus 1 times n minus 2 times n minus 3 ... all the way down to 1. So n factorial, like 12 factorial would be 12 times 12 minus 1 would be 11, 12 minus 10, 12 minus 3, 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way down to there. So that's factorials. And you might see factorials appearing in your series and sequences. Let's take a look at, suppose I want you to evaluate something like 12 factorial divided by 10 factorial. A couple of different ways of doing this. Yes, I could do this on the calculator, and I will. I'm going to do this on the calculator just to confirm. 12 factorial is really 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. All over. 10 factorial, 10 times 9 times 8 times 7 times 6 times 5. Do you see what's about to happen here? I can cancel the 10 over 10, 9 over 9, 8 over 8, 7s, the 6s, the 5s, the 4s, the 3s, the 2s. The 1. What am I left with? 12 times 11, which is 132. Let's try it on the calculator. So 12, go to math, go over to probability, factorial, divided by 10, go to math, go over to probability, factorial, equals 132. There it is. All right, so generating sequences, looking for sequences. There's a lot more going on with something called sigma notation. There's a lot more going on with sequences that we're not going to cover that you will see in the next class. This is just kind of an introduction, if you will, to sequences and kind of generating sequences. Some of the ones in the textbook that you have to do are a little bit harder. The assignment's really not that bad. Just kind of be careful with it. Spend your time on it. So I want you to go ahead and do homework 13.1. It's on page 971, and I want you to do 11 through 23 odd. And 11 through 23, 11, 13, and 15, you're going to evaluate factorials. And you can do them on your calculator if you like, that's fine. And 17 and 19, 21 and 23 are finding terms, generating like the first 5 terms in a sequence. You'll see in this chapter, you're also going to see this symbol. This symbol is called a sigma, and it means sum, adding things up. We'll talk more about that in the next lesson. And the whole idea of sigma and finding sums. And really, there's no mystery here. Finding a sum means that after you generate the terms, you're just going to add them all up. You know, there's a lot more to it than that, but for the sake of this class, this is all we're doing. So as you look through Chapter 13, you're going to see a lot of other stuff going on. But it's not stuff that we have to worry about. It's not part of this class. This is just an introduction to sequences and different types of sequences and sums. Just a very basic introduction. And in the next class, you'll get a lot deeper into these things. Okay? So hopefully, as we finish up the class, we've only got 2 lessons after this, 13.2 and 13.3, and there's only bits and pieces in both of those as well. As we're finishing up with these, hopefully it's a little bit nicer, a little bit easier, good finish strong here. And as always, as soon as you're done with this assignment, email it to me. All right, guys. Now this assignment will be posted on the Tuesday of class. So this assignment is going to be posted on not Tuesday. I'm sorry, Wednesday. This is the Wednesday class. Wednesday, April 29th. So today should be Wednesday, April 29th, if you're on track. That's the day that this is going to get posted. The assignments are due the next day. I've asked for an extension, but if you're watching this a lot later, you might have run out of time. I'm a little bit worried. The homework is not coming in as good as I hoped it would be. So go ahead. This one's not so bad, guys. These 7 problems really aren't going to be that bad. You shouldn't have too much of a difficulty with them. All right, guys, good luck, and I will talk to you again soon. Bye.